Assalamu alaikum everyone. Imagine your APIs goes viral overnight. Everything is working perfectly until suddenly one user or maybe even a bot starts sending thousands of requests every minute. Your CPU usage spikes, your database starts struggling, real user can't log in anymore, and your server eventually crashes. Now here is the interesting part. The problem isn't your business logic. The problem isn't Node.js. The problem isn't even Redis. The real problem is you never controlled your traffic entering your system. And this is exactly why every backend system from Netflix, GitHub, Stripe, Cloudflare to Google uses rate limiting. In this video, we are not just going to install an npm package and call it a day. We are going to build our own production style rate limiter completely from scratch using Node.js, TypeScript and Redis. I am going to explain why every design decision exists. For example, why do we use Redis instead of storing counters in memory? Because memory only lives inside a single server. The moment server restarts, every counter disappears. Redis keeps the data outside your application, so every server can share the same source of truth. Why does in-memory rate limiting completely break in distributed systems? Imagine you have 3 API servers behind a load balancer. A user sends 90 requests. Server A sees 30, server B sees 30 and server C sees 30. Each server thinks the user is still under the limit, even though they have already made 90 requests. That is why shared stored like Redis is essential. Why do companies prefer a sliding window over a fixed window? Think of a movie theater. A fixed window resets the ticket counter exactly every hour. Someone could buy 100 tickets at 2:59 p.m. and another 100 at 3 p.m. Technically, they followed the rules, but they still overwhelmed the system. A sliding window continuously looks at the last 60 seconds, making the limit much fairer and smoother. Why is Redis perfect for this problem? Because Redis is incredibly fast, stores the data in memory, supports automatic key expiration, and provides automatic operations. That means thousands of requests can safely update the same counter without corrupting the data. And what happens if Redis itself goes down? Surprisingly, many production systems intentionally continue serving requests instead of blocking everyone. This is called a fail open strategy. Losing rate limiting for a few minutes is often better than taking your entire API offline and locking out every legitimate user. This isn't just a Node.js tutorial. This is a system design tutorial where you learn how real backend engineers think before they code. By the end of this video, you'll understand not only how to build a scalable rate limiter, but also why it works and what problems it solves and what trade-offs exist in real production systems. So if you are serious about becoming a backend engineer, not just someone who copies code from AI, let's get started. Before we start coding, one quick thing. I have also written a detailed article that goes alongside this video. It includes the complete source code, code explanations, diagrams and everything we built today. So if you ever want to revisit a concept or copy the implementation later, you will find the link in the description below. For this tutorial, I have also prepared a project called EN Tutorial Code and I have opened it with cursor. We'll build everything step by step. And more importantly, we'll discuss the system design decisions behind every piece of code we write. Why we are using Redis, why we are choosing one algorithm over another, and why trade-offs we are making along the way. Alright, let's get started. First of all, let's open the inbuilt terminal. Since we are going to build this project with Node.js, Node.js must be installed on your system. If you install Node.js successfully, let's init package.json. The package name will be Redis Rate Limiter. Okay, version, okay. In entry point will be server.js, and test command, let's not use them, just use the default. Okay, everything is okay. We have generated this package.json. Then we are going to install few packages later. Before that, I'm going to create a new folder. The name of the folder will be, and inside src folder I'm going to create a file. The name of the file will be server.ts, and we are going to build this project completely using TypeScript. By using TypeScript, it will allow us to do some validation and static typing, so we won't get any unnecessary or foolish errors. First of all, let's create a function const start server is equal, this is going to be a async function, async. Now I'm going to create a try catch block as well. In here I'm going to handle the error, and inside error I'll say fail to start server, and this is going to say the error, and in here process.exit on. Okay, that's totally fine. Let's install some of the packages. npm install .env, then I'm going to use Express, which is a Node.js framework, and IO Redis for handling Redis, UID, this is for generating unique ID. So let's just, and for TypeScript I'm going to install a few dev dependencies. npm install @types express, then @types node, then @types /UUID. Don't forget to add this d flag. It will say it is going to be a dev dependency. Okay, here we have installed express node and UUID types. Additionally, I'm going to install two more packages. I'll tell later what each of them do when I'm going to use them. npm install ts node dev, and TypeScript itself, both of them will be dev dependencies. So let's install it. Next, I'm going to create a tsconfig file. tsconfig.json, and I'm just going to paste this configuration. Don't worry, I'll be if you want, you can just pause for a few minutes and copy everything from here. Otherwise, you can get the same file inside my blog post. Just copy from there and paste it here. Okay, next I'm going to create another file, app.ts. In here, let's import Express. Import Express from Express, and in here I'm going to export the app by default, and we don't need this get request. In here I have created instance of this Express API. Next, I'm going to set up middleware, and by default we need to set up these two middleware, use and express.json and app.use express URL encoded extended true. Those two lines are probably some of the most common lines you'll see in any Express application. Those two lines aren't just about parsing data. They are the first stage in preparing an incoming request for rest of your application. Their job is to transform new HTTP request bodies into JavaScript objects. So every middleware and route handler that follows can work with clean structured data. Next, app.set trust proxy on, and in here, by enabling trust proxy, Express trusts the proxy and uses original client IP from forwarded headers. From a system design perspective, this ensures our rate limiter makes decisions based on their real user, not the proxy sitting in front of our server. Without this setting, Express sees the proxy's IP address, not for real client's IP address. Now let's create the middleware. In here I'm going to create a folder, middleware. In here I'll have rate limiter. I forget .ts extension. TS. Okay, I misspelled it. It would be limiter. Okay, now I'm going to create a class, export class limiter. Inside this class I'm going to create two variables, private. Okay, actually let's create the Redis service at the same time. So I'm going to create another folder. The name of the folder will be service. Inside service will have Redis service. This is also a class. Let me just export this Redis service class. Export default Redis service. Okay, now we can import it here, Redis service, and we have imported this Redis service. It is declared, but it okay. Now let's create another private variable, default. Inside this default configuration, all of our configuration will be rate limit config, and let's create this rate limit config inside a new folder, types. Inside types will have index. Again, I have copied all of those interfaces from the article and pasted them here. If you are following along, you can simply pause the video and type them yourself, or just copy and paste them from the article. You will find the link in the description. We only have three interfaces here: rate limit config, rate limit info, rate limit response. Okay, here we have used it, so let me just import it. Now let's create a constructor. This constructor will be responsible for initializing our rate limiter. Now let's initialize the Redis service. Redis service is equal Redis service dot get instance. Okay, we haven't created this get instance function yet, so we are going to create that. Actually, in here I'm going to create this get instance function. Think of this Redis service as communication layer between our application and Redis. Instead of letting every file talk directly to Redis, we keep all Redis related logic in one place. From a system design perspective, this follows the single responsibility principle. If we ever change our storage engine or update our Redis logic, we only need to modify this file. First of all, let's create a few functions. First, we have created get instance function. Similar to this function, I am going to create another function which is going to be get client. Public get client. And similar to this function, I am going to create another function, and this function will be public static, and this is only public. And the next function we are going to create is async check fixed window. Let me copy this and paste it below. Instead of fixed, this would be sliding window. Again, let me copy this and paste it below. Rate limiting info, get rate limit info. Let me create another function below. It would be reset rate limit, and again I'm going to create another function. This is going to be disconnect. I'll explain each of those functions one by one in here. After this class, I'm going to declare two private variable, private client Redis. This is going to be type of Redis. This Redis will come from IO Redis. So we need to import this IO Redis. And again, I'm going to create another variable. The variable name will be instance, and this is going to be type of Redis service. This is going to be static variable. Here we have two variables and we have a few functions below. In between them, I'm going to create a constructor. In here, this dot client is equal new Redis. The first parameter will be Redis URL. The URL we are going to set inside a config file. The config file we are going to create inside a config folder. Inside config will have a index file, index.ts. I just copied this from my source code. And remember one thing, if you are typing it by yourself, that you must specify all those environment variables that starts with process.env. After whatever it is written, you need to write it down inside .env file. I'm going to create the .env file. .env. Inside .env will have port. The port number we are going to set 3000. Then we are going to set Redis URL to this Redis : /localhost 3679. Then the rate limit window millisecond will be 6 seconds actually, and the rate limit maximum request by default is going to be 100 actually. Inside config we only have this config variable. This is actually a object, and inside this object we have port, we have Redis, we have rate limit. Inside Redis we have this URL, and inside rate limit we have few more keys. Those are window, millisecond, maximum requests, and strategy. Now the first parameter in this constructor is going to be config.redis.url. Afterward we'll set this is actually going to be an object retry strategy. This is going to be a camel case retry strategy times, and we'll set delay const delay is equal minimum times multiplied by 50 2000, and we are going to return the delay as well. Let me just get rid of all of them. I get them by autocomplete, and we haven't imported this config file. I guess I need to do like this. After this retry strategy, we need to specify maximum retries per request is going to be actually 3. We should show error or connected successfully. Let's see this .client.on error. If we get any error event, then it will console log the error. If we get connected to Redis server, it will say Redis connected successfully. Why we are calling get Redis instead of writing new Redis service? The answer is singleton pattern. A singleton means only one object of a class can exist throughout the entire application. Let's create the function. This is a static function. In here the return type will be Redis service. Then we'll check if Redis service dot instance. If there is no instance in the Redis service, then we are going to create the instance. Actually Redis service dot instance is equal new Redis service, and we are going to return Redis service dot instance. The first time get instance is called, here isn't any Redis service yet, so it creates one. Every call after that simply returns the same object. Think of it like your home's Wi-Fi router. You don't install a new router every time someone wants internet. Everyone connects to the same router. Same idea applies here. Now in the rate limiter, I'm going to pass a config parameter in the constructor. Okay, so whenever we call this function, we need to pass this config, but once we add this question mark, the config is going to be optional, and the config will be type of partial rate limit config. Notice the question mark. That means the configuration is optional. You create a rate limiter without passing anything, or you overwrite only settings you need. Next, we need to define the default configuration. This default config is equal window millisecond. It is going to be 1000 multiplied by 6, and maximum request is going to be max request is going to be 100 by default. Then strategy is going to be sliding, and key generator will have key generator in here. Require, we don't need to define anything for this type, and require here rate limit colon $, request.ip, then we'll have $. Okay, actually this is going to be 60, so it will be 1 minute. The time window is 1 minute. 100 requests per minute. We use sliding window algorithm, and the rate limit key is created from the client's IP address and requested route. For example, if the client IP is 192.168.1.10 and they are requesting API /users, the key becomes rate limit colon the IP and colon this is the route actually. Okay, there is no 100. This is actually suggesting me nothing else. Why you need this key? This key is required for every IP gets its own counter for every route. Finally, let me write this line config. Actually, there will be 3 dot, not 2. If we pass our own configuration, it replaces the default. For example, if we create new rate limiter max request 10, now everything stays same except max request 10 instead of 100. This approach gives us sensible defaults while still allowing complete customization whenever we need it. Now let's export it. Export const rate limiter is equal new rate limiter. Instead of creating a new rate limiter everywhere in our application, we create one ready-to-use instance. This line creates a rate limiter using all of default configuration we defined earlier. Now we are going to create a new function, middleware. This is the heart of our rate limiter. Here, let's create public middleware, then config * and partial rate limiter, and we don't need this request handler here. Okay, let me close it. With this middleware method, we'll create an express middleware that checks every incoming request before it reaches our API. Const final config is equal this dot default config, then config from the parameters. Here we merged the default settings with custom configuration. This way custom values replaces only settings we want to change. Next we'll return our actual express middleware. Return, it is going to be a async function. We are going to return async, and in here we'll take 3 parameters: request, response, and next. Let's define types for each of them. This request, this response will come from express. Let's import them from express actually. Request, response, next function. Then in here I guess I made a spelling mistake. Final config. This function runs every time a request arrives. The first thing we do is generate a unique request ID using UUID. Okay, const request ID is UUID v4. Import from UUID v4. Actually we are importing v4 and naming it UUID v4, and here we are using that. This ID helps us trace a request through logs and debugging. After that we generate rate limit key. Const key is equal final config dot key generator. Key generator, in here we are going to pass request, and before that we should do like this. By default it is based on client's IP and requested route, so different user gets different counters, and even the same user has separate limits for different APIs. Now comes the most important part. Now we are going to create result variable. This is where we are going to check rate limit based on strategy. Result is equal final config dot strategy is equal fixed. If it is fixed, then await this dot Redis service dot check fixed window. In here we are going to pass key, then we need to pass final config dot window millisecond, then we are going to pass maximum request final config dot maximum request, and again in here let me just copy this line actually and paste it here. Instead of check fixed window, we are going to check sliding window in here. Here we simply ask which strategy are we using. If it is fixed window, we call fixed window algorithm, otherwise use sliding window algorithm. Notice how middleware doesn't know how either algorithm works. It simply delegates the work to the Redis service. Don't worry, we are seeing this error because we actually didn't create anything in check fixed window and check sliding window, so therefore it is giving me an error. It is not allowing to provide any parameters in those function. Now we need to set rate limit headers. Res dot set header is equal x rate limit final config dot maximum request. Let me copy this line, paste it below 3 more times. This time we are going to set header for rate limit remaining. This is going to be result dot remaining. Okay, we are going to set header for reset, and it will be math dot sail and result dot reset divided by 1000. Again we need to set header for ID as well. This is going to be request ID. Once we get the result, we add useful HTTP headers like maximum allowed requests, remaining request, when the limit resets, the request ID. Those headers help clients understand their current rate limit status. Now we check most important condition, if result is allowed or not. If result dot allowed, if it is not allowed, actually I am getting too much error. Let me just create those two check fixed window and check sliding window, those two methods properly. Check fixed window. This method answers one simple question: can this client make another request right now? Let me just pass all the parameters we need for this method, and we need to define return type as well. We are going to return promise. In here we are going to return allowed. This is going to be boolean. Then we are going to return current. This is going to be a number. Then we are going to return remaining. This is also going to be, then reset. This is also going to be a number. Let me just copy this actually and paste the same type for sliding window as well. Okay, we are going to return promise from sliding window as well, and we are going to take same parameters for sliding window. Let me just paste it here. Now let's get the current time and generate a key. This window key is a unique key for current time window. Suppose our window is 1 minute. Every request within the same minute will generate the same Redis key. For example, this is our key. When the next minute starts, the number at the end changes, creating a completely new key. That means every minute gets its own request counter. Now let's use a new Redis transaction. Const multi is equal this dot client dot multi. A transaction lets us execute multiple Redis commands together. Inside it we queue two operations, multi dot incur window key, then let me copy and paste it below. This will be window key again, but this is TTL. This incur increases the request counter by 1. PTTL asks Redis how much time is left before this key expires. Then with this, results is equal await multi dot exec. Then we execute both commands. If the transaction fails, we stop immediately because we can't trust the result. Next, we read the values. For that, we need to create a if condition. If there is no result, then we are going to throw an exception, throw new error, Redis transaction failed. Then const current is equal results 0 1 as number or 0. Then again we need TTL is equal results 0 actually 1 and 1 as number or window ms. Current is the number of requests made in this window. TTL is how many milliseconds remains before the counter resets. Now there is one small but important check. If TTL equal minus 1, then we'll do like this. Await this dot client dot p expire window key, then window ms. If the key doesn't already have an expiration time, we set on. Otherwise, this counter would stay in Redis forever, wasting memory. Finally, we calculate how many requests are left. With this, const remaining is equal math.max 0 maximum request minus current. Then create another variable, const reset is equal now plus TTL, and this is where window will reset. Then we return everything the middleware needs. Return, and we are going to return a JavaScript object, therefore I am using this curly braces. For this we'll need allowed. We are going to check if current is less than or equal maximum request. If it is less than or equal maximum request, then it will be returned as true, otherwise false. Then current will return current, will return remaining, will return reset. You see there is no error in this check fixed window method. If the current request count is still within the limit, the request is allowed. Otherwise, the middleware returns a 429 too many requests response. This algorithm is simple, fast and memory efficient. The trade-off is that users can sometimes make a burst of requests right at the boundary between two windows, which is why we'll also implement sliding window strategy. A sliding window strategy is very much similar to this, therefore I'm just going to copy and paste it here. You see it is not showing any error, but we need to change the logic in between. Now let's take a deep look into sliding window algorithm. Unlike fixed window, this algorithm doesn't reset every minute. Instead, it always looks at the last 60 seconds from the current movement. That makes it much more accurate. First, we calculate the current time where our window starts. So we declared now, then we are going to replace this window key with window start. If the current time is 10:30 p.m. and our window is 1 minute, then we only care about request made after 10:29. Next, we create a Redis transaction. Just like fixed window, we are using the same Redis transaction. In here we are going to use Z-add, and this is where we need to put key, then now, then a string of now dash math.random. With this, the first operation stores the current request. Here we use Redis sorted set. The score is current timestamp and the value is a unique string. Think of it as keeping a timeline of every request. Now we remove requests that are too old. For that we are going to use another function z remaining by score, and in here we need to set the score key 0 and window start. Any request older than our sliding window is deleted automatically. So Redis only keeps requests from the last 60 seconds. Next, with zcard we count how many requests are left. This tells us exactly how many requests were made during the current sliding window. Then we are set an expiration time using pexpire. Let me copy this and rename it pexpire, and we'll set key and window ms. This ensures Redis automatically clean up unused keys, preventing memory from growing forever. After executing the transaction, we calculate how many requests remaining. For sliding window, we don't need TTL, we only need current and remaining. Here for result, the first index is going to be 2, and within 2, the index will be on, and for remaining max, math.max is 0, maximum requests, current, everything is same. Now we need to know when the client make another request. For that, we find oldest request is still inside the window. Const oldest stamp is equal await this dot client dot z range. In here we'll pass key, then 0, 0. This is start and stop time. Then we'll set with scores. Since the sorted set is ordered by timestamp, the first element is the oldest request. If that request happened at 10:30 p.m., our window is 60 seconds. Then the limit resets at 10:31 p.m. That is exactly what the codes calculate. OLD, oldest timestamp. Then we are calculating the reset time. Oldest timestamp length greater than is 0. Then we are just parsing the oldest timestamp and getting the second element. Then we are adding Windows maximum. This is on condition, this is another condition. Now we are returning all those necessary things. So what is the biggest advantage of sliding window? Imagine the limit is 5 requests per minute. With fixed window, a user could send 5 requests at 10 hours, 30 minutes and 59 seconds, and another 5 at 10 hour, 31 minute and 01 seconds. That is a 10 request in just 2 seconds. Sliding window prevents this because it always looks at the previous 60 seconds, no matter when the request arrives. That is why it is more accurate and provides fairer rate limiting, although it uses a little more Redis memory than fixed window approach. Let's get back to the middleware. If the user has exceeded the limit, we block the request. We calculate how long they need to wait. For that, let's create a new variable, retry after math.sail. In here, result.reset minus date.now, NOW, and after that we are going to divide it by 1000. Then we are going to set header. Let me just copy this and paste it here. X rate limit retry after, this will be dash after, retry after. From here we'll return res.status with 4 to 9. Don't worry, I'll explain what this means. Dot JSON will return a JSON formatted object. Okay, in here we'll say success is false. We'll give the details of the error. Code will be rate limit exceeded. Then we'll send a message. The message will be too many requests, please try again later. Then we'll say retry after. Then we'll set limit is going to be final config dot max request. Then remaining is going to be 0, and reset is going to be sale request dot reset by 1000 divided by 1000. Sorry, this will be result dot reset divided by 1000. Then we are going to pass the request ID as well. Request ID. Okay, let me explain this again. With this we are returning 429 response status. The HTTP status code 429 means too many requests. The response also includes helpful information like error message, retry time, request ID. Then let's create another object, and we need to store that inside request dot rate limit. Actually it will show us an error, therefore I'm going to use as any. Okay, in here we'll say limit. This limit will come from the final config dot maximum request, then current result dot current. Then let me copy and paste it 2 more times. This will be remaining. Then we'll set reset. This is going to be reset time actually, and we'll call this next in here. After setting all those properties and values to this rate limit inside this request, let me explain this again. If the request is allowed, we store rate limit information. Now other middleware or controllers can access this information if needed. Finally, we call next. This passes control to the next middleware or the actual API route. One more important thing, let me take all of this inside a try catch block. Catch, if there is an error, then we'll handle this error as well. Okay, let me just copy this simple code from the blog post. I have included the link of that blog post in the description of this video, and let me copy all other code and paste it in here. Okay, now our middleware function is completed. Okay, here we are getting an error, therefore I have used this comment @ts ignore. With this we won't see any error. Here is the documents from Redis. It accept key, start and stop number, then with scores, so everything is right. I'll include the link of this docs to the description of this video. You just need to select the proper language. If you are using Python, you just need to select this. since I'm using JavaScript IO Redis, therefore this is the correct option for me. Now let's create this get client method. First of all, the return type will be Redis, and this Redis will come from Redis IO Redis. Here it is. So I'm just going to return this dot client. Our Redis client is stored inside Redis service as a private property, so other parts of the application shouldn't directly access this dot client. Instead, whenever another part of the application needs this Redis client itself, it will call get client function. In simple terms, get client function acts as a controlled gateway to our Redis connection. Now open server.ts file. Inside this try catch block, let me just Ctrl Shift I for reformatting it, and then const Redis service is equal Redis service dot get instance. Here we are just initializing Redis connection, then we need to verify Redis connection. For that, use await Redis service dot get client dot ping. Let's console log this so you can understand. Then from here I'm going to start the server with this app.listen. The port will come from this config dot port. We need to import it properly. Config. Okay. Yeah, now we are importing properly. Then we are going to declare a callback function in here. Now I am console logging saying server running on port number. Then rate limiting strategy. It will say the strategy. Rate limit maximum request per this millisecond. Let me explain this function again. This is a start server function. The reason this function is async is that we want to verify our Redis connection before starting the server. Inside the try block, we first get our Redis service instance. Remember, we implemented Redis service using the singleton pattern. So this gives us the same Redis service instance throughout the application. We verify that Redis is actually available. The ping command is a simple Redis health check. If Redis responds successfully, we know that our application can communicate with Redis. Once that is successful, we log Redis connection verified. Only after Redis has been verified, we do start our Express server. Inside the callback, we are logging some useful information in here. This is useful during development because when the application starts, we can immediately see which port we are using, which rate limiting strategy is active, and what limit has been configured. Finally, everything is wrapped inside try catch block. If Redis isn't available or something goes wrong during startup, we log the error and terminate the process. The important idea here is that Redis is a required dependency for our rate limiter. So we verify that connection before accepting request. Let's call the start server function in here. Let me handle graceful shutdown. Process.on async. We'll have a callback function in here. Inside this callback function, we're going to console log that seekterm received shutting down gracefully. Then we are going to create an instance. Redis service is equal Redis service dot get instance. Then we are going to disconnect Redis service dot disconnect. Then process dot exit 0. This part handles graceful shutdown of our application. Let's understand why we need this. When our Node.js application is running in production, it can receive a seekterm signal when the server is being stopped or restarted. For example, during a deployment or when a process manager asks the application to shut down, instead of immediately terminating the process, we listen for the signal. with SIGTERM is received, we first log a message so we know that shutdown has started. Then we get our Redis service instance. And most importantly, we properly close the Redis connection. This is important because we don't want to leave an open Redis connection behind when our application is shutting down. Finally, once Redis has been disconnected successfully, we exit the process with status code 0. The 0 indicates that the application is shutting down successfully. Let me copy this and paste it below here. This time, instead of SIGTERM, make it SIGINT. This is very similar to SIGTERM handler we just discussed. The main difference is what sends the signal. Here we are listening for SIGINT signal. SIGINT is commonly triggered when we manually stop a Node.js application. For example, by pressing Ctrl+C in the terminal. When that happens, instead of immediately killing our application, we perform a graceful shutdown. So now we have handlers for both SIGTERM and SIGINT. Now open your package.json. In here I am going to create a few scripts. First one will be build. For that we are going to use the command tsc. Then I am going to create another command start. The command will be node dist server.js. Then dev for dev ts node dev respond transpile only server.ts. Then this is optional update. If you want to create it, then create it. I just create it for every project, but you don't need to. npx npm check just for updating all of our packages. Here tsc is TypeScript compiler. It takes our TypeScript source code and compile it into JavaScript, usually inside dist directory. Let me show you. npm run build. Here we have created this dist folder. Next we have start. After the TypeScript code has been compiled, this command starts the generated JavaScript application using Node.js. So the typical production flow is build the TypeScript code, then run the compiled JavaScript. For development, we have this dev command. This allows us to run TypeScript application directly during development. Let me start our Node.js application. Start npm run start. Redis connected successfully. Redis connection verified. Server running on port 3000. Rate limiting strategy is sliding. Rate limit 100. Request per 60,000 milliseconds. One more thing, have you noticed or not? Let me just run it again. npm run start. Just click on Ctrl+C. It is just saying SIGINT received, shutting down gracefully. So this event is calling actually. Again, I'm going to use npm run dev. It will also work, I guess, but it is showing me an error. Cannot read property of undefined file exists. Okay, here is the problem. We are not going to use ts node dev. Instead, we are going to use TSX, which is the latest package for TypeScript. So we are going to use that, and then I'm going to install this TSX package inside my dev dependency. Just run this npm install -d then TSX. Once it is installed, then you should see that inside your dev dependency. If you are seeing them, then you can just run this command npm run dev. It should work properly. npm run dev. Yeah, it is working. Redis connected successfully. Okay, here I misspelled it. This folder name should be mi, not mi. Middleware. Inside it we have rate limiter.ts file. Inside it we have this instance. We exported it. Rate limiter is equal new rate limiter. In here I'm going to create another instance. Export const standard limiter is equal rate limiter dot middleware. Now we are going to use it in our app file. Inside our app.ts, I'm going to set a middleware app.use. The middleware will be standard limiter. Okay. The important thing here is that middleware returns a function that Express can use as middleware. So we are basically converting our rate limiter class into something that Express understands. Finally, we attached the middleware to our application. Because we are using app.use, this middleware will run for every request that reaches this Express application, unless we later configure specific routes differently. Let's create our first route, app.get request. This will be type of request and response. This is type of Express response. Then this is a callback function. So we are just declaring the callback function. Here we say response.json. We are going to return JSON formatted data. In here, success is going to be true. Then message will be rate limiter API is running. Then rate limit request as any dot rate limit. Actually this will come inside data, so let me just data. Inside data will have rate limit, then we'll have time stamp new date to ISO string. Okay, let me import this request and response manually from Express. I guess this is not working, so let me just import them. Okay, yeah, here it is. There is no error now because this middleware is registered before our route. Every request to this application will pass through this rate limiter first. So when a client sends a request to /, the request doesn't immediately reach our route handler. If the request is within the allowed limit, the middleware calls next function. The request continues to our route. If the limit has been exceeded, the middleware stops the request and returns a 429 too many request response. Now let's look at the route itself. This is simply a test endpoint that confirms our application API is running. But there is one interesting part here. Our rate limiter middleware can attach rate limit information to the Express request object. For example, this information can tell us the configured limit, the current request count, how many requests are remaining, and when the limit resets. We are using as any here because the default Express request type doesn't know about our custom rate limit property yet. For testing API, I'm going to use Postman. You can use any other tool you like, but this works great. So let me show you. This is the backend URL, which is http://localhost:3000. I just made an environment variable. Just click on this collection name, and in here in the variable I have created this variable, so I can use this backend API everywhere. Instead of this, to create a new collection, you just need to click on here and collection. So I'm not going to create a new collection. Instead, I'm going to work with my existing one. So here is my new request. If you haven't used Post API before, creating a request, very simple. Just add request. Then from here, select the method. I'm going to select it, and here is the URL. You can also use the variable backend API. Both of them are same. And let me just make a request. There is an error. The error is with the URL. So let me just cut it and again make the request. Here is my request. It is saying success true, message rate limiter API is running. Then inside data we have rate limit and timestamp. This is the timestamp when we made the request. Then the rate limit, inside rate limit we have limit, current, remaining, how many requests are remaining, and when it is going to reset. So this is time in millisecond. Okay, this is the remaining request. If I make another request, it will say 97. Again make another request, it will say 96 remaining, and the current request is 4. There are some certain standard for each type of API. For example, there are some certain standard for public API, for Auth. There are some certain limits for Auth. There are some certain limit for strict API. So we are going to make limiter for all of them, actually using the standard Here we are going to create API limiter. Let me copy this and paste it here. API limiter. In here I'm going to say create. Actually we haven't created this function yet, so I'm going to create this function below this middleware. Public create route limiter. Okay, in here it will take a few parameters. First one is maximum request. This is going to be number. Then we'll have window millisecond. This is optional field, therefore I'm just giving this question mark. This is also going to be number. Again, strategy, this is also optional field and can be either fixed or sliding. And in this function we are just returning this dot middleware maximum request. Then actually we need to specify this object. Here it takes configure. The configure, this is rate limit config. It has Windows millisecond, maximum request, strategy, key generator, etc. So we need to pass parameter in same format. Therefore the maximum request Windows millisecond, this would be actually Windows millisecond. If it doesn't exist, then it will say this dot default config dot Windows millisecond. Again, same goes for, let me copy this, and same goes for strategy, strategy. Okay, let me make it like this so you can see better. And below here for public API we are just creating this API limiter, and we need to call this function create route limiter. In here the first parameter maximum request is going to be 1000 for public and 36000 and 00. Actually 3 million. Window millisecond is going to be 3 million. Then it will ask for either fixed or sliding window, so we are going to select sliding window. The purpose of this method is to make it easy to create difficult rate limits for different routes. For example, maybe our normal APIs allows 100 requests per minute, but a specific endpoint needs a much higher limit. Instead of manually creating a complete configuration every time, we can simply call create route limiter with the values we need. Here we are creating a new limiter that allows 1000 requests within 1 hour using sliding window strategy. And because create route limiter returns express middleware, we can attach this limiter directly to route. Here let's create a public route, get API public and here API limiter. This time we didn't use standard limiter, instead we have used this API limiter. And again I'm going to use this same, let me copy this and paste it here. And actually let me copy this JSON response. I'm going to paste here this JSON response. Message is going to be true again. This time let's write public API endpoint. Then data is going to be the same. Just let me take it above so you can understand better. Timestamp and rate limit. Before our route handler runs, API limiter checks whether the client has exceeded the configured limit. In our case, API limiter was configured for 1000 requests per hour using the sliding window strategy. If the client is within the limit, the middleware calls next and the request continues to our route handler. If the limit has been exceeded, the middleware stops and the request returns 4 to 9 too many request response. The route handler won't execute. Let me try it with Postman. In here, this is the URL with Backend API. I have /API/public. This is the correct URL endpoint. And let's try it. Success true, message public API endpoint, timestamp this, and everything is working as expected. The API responds successfully. Let's focus on rate limit object. The first limit is 1000. That is because we configured our API limiter to allow 1000 requests per hour. Then we have current, which is currently 2. That means Redis has tracked 2 requests from this client within the client sliding window. Because our limit is 1000 requests, we have used 2. The remaining is 1000 minus 2, which gives us 998 requests remaining. Finally, reset time tells us when the current rate limit window will reset. I made this calculation so you can understand better. 1 second equal 1000 millisecond, 1 minute equal 60 seconds, and 1 hour is equal 1 minute multiplied by 60, which is 60 minute is equal 1 hour, and we have used 1 hour instead of that long number. Now I am going to create another limiter. Let me copy this line and paste it below. Let me zoom it little bit so you can see better, and whatever goes beyond this line will start from the next line because I have used this odd drop. So here I'm going to make this variable name auth limiter, and this auth limiter will set it 5 requests per 15 minutes. So make it 5 and 15 minutes, this is 1 minute multiplied by 15 multiplied by 15 is equal to 15 minutes. And in here, instead of sliding window, we are going to use fixed window. Here we are saying that an authentication endpoint can be accessed a maximum of 5 times within 15 minutes. With this fixed window, we are going to calculate rate limit using a fixed 50-minute time window. Again, go to app.ts. Let me copy this and paste it below. And let me change the request. This is going to be post, not get. And in here, API auth. Then instead of public, this is going to be login. And instead of API limiter, it will be auth limiter. This time we are not going to send the whole data. Instead, we are going to send only this rate limit. Let me copy and paste it here. This is our login endpoint. We have specifically applied the auth limiter middleware to it. We use post here because login requests normally send data such as username, email or password to the server. Because auth limiter is placed before our route handler, every request to this login endpoint must pass through this rate limiter first. If the client is still within the limit, the request continues to the route handler. If the client exceeds the limit, the rate limiter immediately returns a 4 to 9 too many request response, and this route handler won't execute. Finally, if the request is allowed, we return a JSON response containing the login message and the current rate limit information stored in request.rateLimit. In Postman, I have created another request, and make sure the request method is post. This is very important for a post route. And in body, if you need to pass anything, you can pass in the body. And in here, once I made the request, it is saying that I have got request successful. The server has responded as required. Status code is 200. Let's understand the rate limit information. First, we have limit 5. This tells us that our login endpoint allows a maximum of 5 requests within 15-minute window. Let me create another request. It will say the current is 2 and remaining 3. Limit is 5. If we continue sending requests, the current value will increase and the remaining value will decrease. Once we exceed the limit of 5 requests, our rate limiter will block the request and return a 4 to 9 too many request response. Let's create another limiter. Let me copy this and paste it below. This is going to be strict limiter. Strict limiter. In here I want 10 requests per minute, so for 1 minute I will allow only 10 requests. From app.ts, let me copy this and paste it below. In here I'm just going to use strict limiter instead of auth limiter. So strict limiter, and this strict limiter will be actually sliding window strategy. Previously our auth limiter allowed 5 requests every 15 minutes. Now with strict limiter we are allowing 10 requests every 1 minute. Let me just change this. This will be API. The endpoint must be changed. Go to postman again. Here I have already created this sensitive endpoint. Let me make the request. Here I am getting limit 10, current 2, remaining 8. Now let's create a rate limit status endpoint. This endpoint is mainly useful for administration, debugging and monitoring. Let me actually copy this and paste it below here. I'm not going to respond with this, and I'm going to change the endpoint as well. The endpoint will be API rate limit status. Here we won't pass any middleware. Here in my return block you can get the code. You can just copy and paste it, but I'm going to write it. So I'm going to explain step by step. First of all, let's create a try catch block. Try. Inside the try catch block, first of all, let me get the status. Status is equal await rate limiter dot get. I misspell it. Get. Actually, this is going to be async. The async keyword is important because we are going to communicate with Redis to retrieve the current rate limit information. Get rate limit status, and we are going to paste request in here. And of course we haven't created this function yet, so we are going to create this function first. Below this create router, I'm going to create this public this function. The parameter will be request. This request will come from Express, so let me just import it. I guess it is imported before, so I'm not going to import it again. This method receives the current Express request and return the current rate limit information for that request. The first thing we do is generate the same Redis key that our rate limiter uses. Const key is equal this dot default config dot key generator and request. Remember, our default key generator creates a key based on client's IP address and request path. Using the same key is important because we want to check the exact same rate limit record that the middleware is using. Next, let's return with await this dot Redis service, and from Redis service we are going to call this get rate limit info, which we have created previously. This is the function we haven't created but we just defined. So this is going to be a async function. Async. Okay, so now let's look at get rate limit info method inside Redis service. The purpose of this method is simple. It reads the current rate limit information from Redis without creating a new request count. In here we'll have a few parameters. First one is key, which is going to be string. Then the second parameter will be strategy, which is going to be fixed or sliding. Then the third parameter will be window millisecond. This is going to be number. Then the last parameter will be maximum request. This is going to be number. Then okay, let me just make it rough so you can see it properly. Now the return type will be current number of requests, going to be type of number. The second parameter will be remaining, this is also going to be a number. Then the third parameter will be reset, this is also a number. Here we are receiving 4 parameters. Key identifies the client and endpoint. Strategy tells us whether we are using a fixed or sliding window. Window image, the length of the rate limiter window. Max request, the maximum number of requests allowed. The method returns 3 pieces of information. This tells us how many requests have been made, how many are remaining, and when the limit will reset. Now we get our current time. Then we check the rate limiting strategy we are using. If strategy is equal fixed equal fixed, then do something else, For fixed window strategy, we create the same window key that use when storing the request count. This gives us the current fixed time window. Next, we retrieve the current request count from Redis. If the key doesn't exist, we simply treat the current count as 0. Then we check how much time is left before this Redis key expires. PTTL gives us the remaining time in milliseconds. We have created 2 current. Let me get rid of one of them. Finally, we return the rate limit information. The remaining value is calculated by subtracting current request count from the maximum allowed request. We use math.max so that remaining value can never become negative. The reset value tells us when the current window will expire. Now let's look at other branch. For a sliding window, we first calculate where the current window starts. Then we remove requests that are older than current window. Remember, our sliding window implementation uses a Redis stored set, where each request is stored with its timestamp at the score. After removing expired request, we count how many requests are still inside window. Then we retrieve the oldest request timestamp. We need this timestamp to calculate when the oldest request will leave the sliding window. Finally, we return. If there is an existing request, the reset time is calculated from the oldest request timestamp plus the window duration. If there are no requests, we simply use the current time plus the window duration. So the main idea of this method is that it understands both rate limiting strategies and knows how to read the appropriate data structure from Redis. This gives our status endpoint a consistent response regardless of whether the application is using a fixed window or a sliding window. And inside this get rate limit status from this rate limiter, let me pass all the parameters. First, the key, which identifies the client and endpoint. Second, the current rate limiting strategy, such as fixed or sliding. Third, the configured time window, for example 1 minute. And finally, the maximum number of requests allowed during that window. The Redis service then uses this information to retrieve current rate limit state from Redis. Because Redis operations are asynchronous, we use await here, and notice that we simply returning result from Redis. This keeps the responsibility nicely separated. So overall, this method acts as a small bridge between our Express status endpoint and Redis service, allowing us to inspect the current rate limit information for a particular request. If everything works correctly, we return the status inside our response. We also need to handle the case where something goes wrong. That is why we have this catch block. If Redis is unavailable or the status check fails for some other reason, we return a 500 internal server error response instead of allowing the application to crash. One important point is that this endpoint is intended for admin or debugging purposes. So in real production application, we should protect it with proper authentication and authorization. This endpoint is especially useful while developing our rate limiter because it gives us a simple way to inspect the current rate limit state without manually checking Redis. Now let's test our API rate limit status endpoint using Postman. Make the request and the response we get is this. Let's understand what those values means. We are getting success true, and inside data we have current is equal on. This means on request has currently been recorded for the rate limit key. Actually current is equal to, not on. Next, remaining 98. Our default rate limit is 100 requests per minute. Since we have already used 2 requests, we have 98 requests remaining. And finally, this is the reset timestamp. It is represented as unique timestamp in milliseconds. So it isn't directly readable as a normal date or time. So the important thing to understand is that this endpoint giving us a snapshot of the current rate limit state. This is particularly useful during development and debugging, because we can easily verify whether our rate limiter is correctly tracking requests in Redis. Alright, so here is a situation you have probably run into. Imagine you are testing your API. You are accidentally triggered the rate limit. Now you are locked out of the next minute. Frustrating, right? This is exactly why we need a reset function. It is our get out of jail free card for rate limiting. So let's look at how we build this reset functionality. This is the reset rate limit method and it is part of our Redis service. Key string, then strategy is going to be fixed or sliding. This is also going to be inside single quotation mark or double quotation mark. Now the return type will be promise void. This function takes 2 parameters. Key is the identifier we are tracking. Now here is where it gets interesting. The way we reset is different depending on which strategy we are using. And that's because each strategy stores data differently in Redis. Let's start with fixed window strategy. If strategy is equal fixed, then we need to put like this. What this line does, this asterisk is a wildcard. This searches Redis for every key that matches our pattern. It is like saying give me all keys that starts with user, no matter what comes after the colon. Quick side note here, in production you would want to be careful with keys command. It scans the entire Redis database, and if you have millions of keys, it can slow things down. So when we want to reset, we can't just delete one key. We need to find all keys that start with our base key. And now for the sliding window strategy. This is much simpler. And here is why. With sliding window, we are using a sorted set to store all of our requests. Instead of creating new keys for each time window, everything goes into one key. So when we want to reset, we just delete the single key. Boom, done. No need to search for multiple keys because there is only ever one key per identifier. And that is our reset functionality. It is a simple method, but it gives us the flexibility to manage rate limits dynamically. This reset limit method is part of our main rate limiter class. We only need these 2 lines inside this method. Simple, right? Just 2 lines of code. First we have key. We need to figure out which key we are actually resetting. Now we have our key. We are calling that reset rate limit. We are calling that reset rate limit method we built earlier. Notice we are also passing in this default config.strategy. This is important because remember, the reset works differently depending on whether we are using fixed window or sliding window. So we need to tell our Redis service which strategy we are currently using. Alright, we have built reset functionality in our Redis service. We have created reset limit method in our rate limiter class. But there is still one piece missing. How does an admin actually trigger this reset? They need an endpoint, a URL they can send a request to. That is exactly what we are building now. First, we are defining a post endpoint at API/admin/reset rate limit. Why post, not get? Because we are changing state. We are modifying data in Redis. Get request should be for retrieving data, post for making changes. This line is interesting. We are figuring out which IP address to reset. Admin has two options. They can provide an IP in the request body. Maybe they want to reset a specific user's limit. If no IP is provided, it defaults to request.ip, which is the IP making the request. Now we are calling our reset limit method with mock request. Notice the await keyword. This is an async operation. We are waiting for Redis operation to complete before sending a response. This ensures that when the admin gets the success message, the reset has actually happened. If everything worked, we send back a JSON response. This message includes the IP we reset, which is good for logging the configuration. The admin immediately knows the operation succeeded, which IP reset. If anything goes wrong, we catch the error and send back a 500 status code with an error message. Notice we are not sending the actual error detail to the client. That could leak sensitive information. We are sending a generic message instead. In production, you would want to log the actual error server side for debugging. Let me create a new request. Reset limit. Let me copy this API and paste it here. It will be a post request, not a get request. Let's see. Admin reset rate limit. I am going to make a post request to my admin endpoint using Postman. I want to reset my rate limit because I have been testing and hit the limit. Let me send the request. Look at the response. Actually, I made a breakpoint in here, so you don't need to. And look at the response. Success, great. But wait a minute. Rate limit reset for : on. What is that? I expected to see 127.0.0.on or maybe localhost, but : on, that looks like a typo or some kind of error. And here is the thing, this is not an error, this is actually correct behavior, but it reveals a common issue that a lot of developers don't think about until they see it in action. What is going on here? When I made this request from Postman to localhost 3000, the connection didn't use IPv4's 127.0.0.on. Instead, it uses IPv6 loopback address, which is : on. Your operating system and applications often prefer IPv6 when connecting to localhost. One more thing, if you want to specify your IP, no problem. You can just select this body tab and go to raw. From here, select JSON, not text, actually JSON. From here, just write IP and make sure it is in double quotation mark since we are responding 1 to 3. We are responding JSON. And here in target IP, you see I made this question mark. Then if we don't get IP from both of them, then we'll use unknown, not ID, it will be IP actually, IP. Okay, save it and once again send the request. Let's see, we get the IP, target IP is 1 to 3. Okay, everything is working right now. So here is a scenario that will happen in production. No matter how careful you are, something will go wrong. Maybe Redis crashes, maybe a user sends malformed data, maybe there is a bug you didn't catch in testing. If you don't handle those errors properly, what happens? Your entire application crashes. Users get ugly stack traces, and the worst of all, you have no idea what went wrong because nothing was logged. This is why error handling middleware is absolutely critical for any production API. Here is our error handling middleware. We log the actual error to the console. This is the crucial for debugging. You need to know what went wrong server side. But notice what we send to the client. We are not sending the actual error details. Why? Because that would leak sensitive information. Now the second middleware. This is our 404 handler. It is technically not an error handler, it is a regular middleware. But it is usually placed at the very end of your middleware stack. And there you have it. Our rate limiter is fully functional. We have built, fixed and sliding window rate limiting strategies, Redis backed storage for distributed systems, admin endpoints for managing rate limits, proper error handling middleware, and we handle the tricky IPv6 localhost issue. You now have a production ready rate limiter that can protect your API from abuse and ensure fair resource usage across all clients. Now if you got stuck at any point, don't worry. I have written a complete and step-by-step tutorial that covers everything we did in this video. You will find the link in the description below. The written version includes all the code we wrote, organized and commented, additional explanation and examples, common issues and how to fix them, code snippet you can copy and paste. So if something didn't quite click during the video, or if you want to review a specific section, check out the written tutorial. And if you are still stuck, or if you have questions that the tutorial doesn't cover, you can connect with me personally. I'll try to help as many people as I can. You can find me on Twitter and LinkedIn. All my contact links are in the description below. Don't hesitate to reach out. I remember what it was like to be stuck on these problems, and I am happy to help. Now if this video helped you understand rate limiting better, please take a moment to like this video. It helps YouTube recommend it to other developers who might be struggling with some concept. Comment below. Let me know what part you found most helpful. Subscribe to this channel if you want more content on backend development, API design and Node.js. I publish new tutorials regularly. And speaking of comments, I would love to know what you want to see next. I prioritize topics based on what my viewers actually want to learn. Thank you so much for watching.